Hello, Mr. Sai. Today I present our final project. So, so we have this program. My program is the first I run program to Python 5. So this is the start stream. We have the success information process and the our topic to shorting and moving moving belong to the objects circle. We have the my team. We have Trần Tấn Hiếu, Trần Thành Dũng, and Nguyễn Đình Hoang. So we move to the simulate the final project. We have we rest the start to be in the process. So when we have the model, we have the model of the simulating our final rest. So this have the three most servo. The first servo to control the x-axis, the second servo control the y-axis, and finally servo we simulate the sorting, the moving sorting. We have the construct to turn on and turn off simulate sorting. So we have when we turn on the servo, this motor servo to crowd 90 degree and turn up, move the beam, the positive beam. So we have the one pole to the connect with the camera. When we move the ball, the camera move too, and you see like that, and you see like that in the dream. The center ball in the center camera.
Coming up next, I will talk about the code, how these simulations work. But first, we'll talk about the library, the firmware. The parameter is to import to connect the code with the Python to the Arduino. The CV2 is to processing the image, the numpys and MP for calculate when we use in the code, the Kalman filter for detecting and predict where the circles coming or how it's come, the thin kinder for making the first image designer. We'll talk about a little bit later. And finally is the pillow. First I will declare a window for making the size to introduce the school text with the font and the size. Then I will declare the image or the logo school and show it. Next I will declare the text of the the object, the final project of our group, and the lectures and all the students who work in the group with all the fonts and the size. Coming up next, I will make a start button for start in that window. That start windows for destroy all the window and come next to the video, and the start button is how it work, the color, and till the window still working, I use the command window dot main loop for still work before I click the start button. Then I will import the Arduino COM5 and the servo X at port 8, the servo Y as port 9, and servo S at port 10. And for the board, I will set the mode of servo X in the Arduino on the mode servo, the same to servo Y and servo F. Because we will use the button outside to shoot the ball, so I will declare it in the port number 3 at the mode input. Next is the mini function on how I rotate the servo, which here we have the pin is the gate and the angle is the angle of each servo. For the range each from 0 to the angle I choose +1, the port pin will declare the gate of the servo and it will write down. That's all. Next, Hill will talk all how it works.
In this part, I will talk about the image processing. Firstly, I will call the camera, and then I will call the command filter library. After that, I create a new variable previous circle, and I will set it to none. And I use this formula to calculate the radius of the circle. After that, I will calculate the center value and the center Y value. Then we set the initial position of the servo X and the servo Y within 90 degrees. We set the 90 degree in order to make sure that the camera is at the center of the frame. In the main while loop, I will read the frame from the webcam, and then I will plot the center vertical line and the center horizontal line. This is the center vertical line and the center horizontal line. This is the x1, y1 and x2, y2 of the vertical line, x1, y1 and x2, y2 of the horizontal line. In order to detect the circle, we have to convert the RGB frame into gray frame, and we create a variable circle to contain the value of the circle, including the position and the radius. To detect the circle, we use a half circle detection. The input of the half circle is the gray frame, and we use half gradient method. After many time testing, we choose dB is equal to 1, and the mean distance is 500. The mean distance is the distance between two. The mean distance is the distance between two center points, and then the parameter 1 is equal to 80. This parameter 1 is the threshold of the edge detection. Parameter 2 is equal to 25. Parameter 2 is the accumulator threshold, and the mean radius is equal to 60, and the max radius is 150. After that, we will check the digital pin of the Arduino. if it's in high level, then we will rotate the servo 90 degrees, else otherwise we will rotate the servo 0 degree, and we will check the circle. If there is a circle, then we will convert the circle into number array in decimal, and in order to choose the best circle, we create a chosen variable, and then we will run the for loop in the circle array. If there is not circle before, then the chosen will be equal to y, will be equal to I. If there exists a previous circle, and then we will check the radius of the chosen circle. If the radius of the chosen circle is smaller or equal the radius of the circle at position I, then we will choose the chosen is equal to I. It means that we will choose the new circle close to the previous circle. After choosing the best circle, we will predict the center point of the circle. We use command filter to predict the center point, the next center point of the object. After detecting and predicting, we will plot the boundaries circle with the position x, position y, and the radius. This is the color of the boundary and the thickness of the boundary. The second line is used to plot the center point of the object, and the last three lines is used to plot the predicted point from the command filter. In order to control the servo motor, we will check if the x position is smaller than centered. We will set the pitch increase by 1 degree, and if the position x is smaller than the centered, we will decrease the pitch by 1 degree, and then we will set the calculated angle to the subroutine rotate servo. In order to reduce the fluctuation of the servo, I will increase the width of the center X line by 40 pixels, and to control the servo Y, we will check the Y position. If the Y position is smaller than the CY, smaller than the center Y, BY will increase by 1 degree, and if the position Y is greater than the center Y, we will decrease BY by 1 degree, and then we will set the calculated degree to the rotate servo, to the subroutine rotate servo. And we also want to reduce the fluctuation of the center Y, so we expand the width of the center Y by 20 pixels. After that, we will show the frame by using cv2.info, and we will check if the Q button is pushed, is pressed, then we will escape the white loop and release the video and close on the window.